Hello friends and viewers, let's continue walking our journey of solving miscellaneous equations which can be reduced to the quadratic equation form. Let's look at this question. Solve to find those real values of x which satisfy this equation. Logarithm of 6 times x squared plus 23 times x plus 21 to the base 2x plus 3 is equal to 4 minus logarithm of 4 times x squared plus 12 times x plus 9 to the base 3 times x plus 7. Now this is a unique problem which combines the properties of logarithms and ties them up with quadratic equation concept. So the first thing that we would like to look at is to see if we can factorize these two expressions within the brackets. Let's look at this. 6x squared plus 23x plus 21. If this were factorizable, we need to be in a position to find two numbers whose product is 6 times 21, which is 126, and whose sum is 23. Well, let's look at this. 6 times 21 is 126, and the sum of the digits is 1 plus 2 plus 6, which is 9. So this must be divisible by 9, right? So this is 9 times 14. Well, it really does work because 9 plus 14 is 23 and 9 times 14 is the same as 6 times 21. So this should be factorizable this way. This is 6x squared plus, let's split it this way, 9x plus 14 times x plus 21. So the common terms from this would be 3x times 2x plus 3 plus 7 times 2x plus 3. Or in other words, we could rewrite 6 times x squared plus 23 times x plus 21 as 3 times x plus 7 times 2 times x plus 3. Right? Well, the other expression is a lot more easier to deal with. 4x squared plus 12x plus 9, because we could write this as 2x the whole squared plus this 9 could be written as 3 squared. This middle term is a lot easier to figure out by now. If we take this as a, this is b, then this 4x squared plus 12x plus 9 could be written as a squared plus 2 times a times b plus b squared, which is nothing but a plus b the whole squared, right? So this should be 2x plus 3 the whole squared. Now let's plug these two back into the given equation. So we could rewrite the given equation this way, that is logarithm of 3x plus 7 times 2x plus 3 to the base 2x plus 3, and we bring this term to this side plus logarithm of 2x plus 3 the whole squared to the base 3x plus 7 is equal to 4. Right? Now we're going to use two important properties of logarithms, which is that logarithm of a to the base c plus logarithm of b to the base c can be written as logarithm of a times b to the base c, and logarithm of x power n to the base c can be written as n times logarithm of x to the base c. So this is in the form logarithm of a times b to the base c. So this can be rewritten as log a to the base c plus log b to the base c. So we could rewrite this, the first expression, as logarithm of 3x plus 7 to the base 2x plus 3 plus logarithm of 2x plus 3 to the base 2x plus 3. Right? Plus, now for this we could use the next one. So this term can be rewritten as twice logarithm of 2x plus 3 to the base 3x plus 7. This is equal to 4. Now, for this problem to be really valid, in general, logarithm of a to the base b is defined for a greater than 0 and for b greater than 0. This is the basic norm. So, on this basis, we should understand that the base 2x plus 3 should be greater than 0 and 3x plus 7 should be greater than 0, right? Whether you look at it here or here. Of course, if this is the case, then logarithm, if this is defined, then logarithm of 2x plus 3 to the base 2x plus 3, this becomes 1, right? We find that here the base and the number within the log are just interchanged in between these two terms, right? That's an important observation. So we also know that logarithm of a to the base b is the reciprocal of logarithm of b to the base a. This is something again which we will be using in this. So let's substitute logarithm of 3x plus 7 to the base 2x plus 3 as t. Then we could rewrite this equation as, this would imply that, so this is directly t plus, of course, this 1 plus, now here we use this fact that logarithm of 2x plus 3 to the base 3x plus 1 would be the reciprocal of logarithm of 3x plus 7 to the base 2x plus 3. So this could be written as the reciprocal of t. Logarithm of this number, that is this, can be written as the reciprocal of t. So 2 times 1 by t. So t plus 2 by t is equal to 4 minus 1, which is 3. Now this is a quadratic equation which can be, we take the LCM and we cross multiply, we end up with t squared minus 3t plus 2 is equal to 0. Right? Or in other words, this can be factorized. This is t minus 1 times t minus 2 is equal to 0. Or this gives us t is equal to 1 or 2. Now, let's go back to our fundamental definition of t here and find out the values of x which satisfy the given equation. According to our definition, t is logarithm of 3x plus 7 to the base 2x plus 3. So let's go back here. So that means logarithm of 3x plus 7 to the base 2x plus 3 is equal to either 1 or 2, right? So let's take the case when it's 1, that's easier to deal with. So 3x plus 7 would be equal to 2x plus 3 the whole power 1 if we remove the log. So that means x is equal to minus 4, right? However, if we substitute x is equal to minus 4, this base becomes twice x plus 3, that would be minus 5, which is not acceptable. And here we would have logarithm of a negative number which is not defined, because 2x plus 3 has to be greater than 0 and 3x plus 7 has to be greater than 0. X is equal to minus 4 does not satisfy, therefore this cannot be a solution. Let's look at the other part, that is logarithm of 3x plus 1 to the base 2x plus 3 is equal to 2. Let's see if we have some solutions there. So that means 3x plus 7 would equal 2x plus 3 the whole squared, using the fundamental definition of logarithms. Or we expand this, we get 4x squared plus 12x plus 9 is equal to 3x plus 7. We simplify this, we get 4x squared plus 9x plus 2 is equal to 0. 9 minus 7 is 2. So we are looking, let's see if we can factorize this. We are looking for two numbers whose product is 4 times 2, which is 8, and whose sum is 9. The choices are obvious, 8 and 1. So 4x squared plus 8x plus 1x plus 2, or this can be rewritten as so this is 4x times 2x plus 1 plus 1 times 4x times x plus 2 times 1 times x plus 1 times x plus 2, that is 0, or 4x plus 1 times x plus 2 is equal to 0, right? Or we have x is equal to minus 1 by 4 or minus 2, right? So let's check out if these things, if these solutions are really possible. So let's verify the case when x is equal to minus 2 and x is equal to minus 1 by 4 separately. Now we have 2x plus 3, this should be greater than 0, but x has to be greater than minus 3 by 2. So this would obviously fail because 2x plus 3 would be minus 1 if x were minus 2. So we would have a negative base and then we'd have, logarithm of a negative number being defined here. All this wouldn't work. So this is not a solution either. Let's check the last option, that is that x is equal to minus 1 by 4. Now 2x plus 3 has to be greater than 0, which means x needs to be greater than minus 3 by 2. Of course, minus 1 by 4 fits this bill. You also have 3x plus 7, that needs to be greater than 0. Of course, x needs to be greater than minus 7 by 3. So both these conditions are satisfied only by this value of x. That is, x is equal to minus 1 by 4. Therefore, x is equal to minus 1 by 4 is the only real solution to this given equation. Hope you loved this problem, which combines the beautiful properties of logarithms and ties them up with the concepts of quadratic equation solving through proper substitution. Please subscribe to our channel and look forward to more interesting videos from us. Thanks for watching.